या कुन्देन्दुतुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमा आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदां जाड्यान्धकारापहा हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्.
Recent advancement and challenges in electric hybrid vehicles technology organized by the Department of Electrical Engineering of Global Institute of Science and Technology, Haldia. It gives me immense pleasure to extend my warm welcome to Honorable Doctor of Literature, Dr. Lakshman Chandra Sheth, Sir, Chairman of Global Institute of Science and Technology, Mr. Ashish Lahiri, Sir, Secretary of Global Institute of Science and Technology, Mrs. Manoshi De Sheth, Madam, Vice Chairperson, ICARE, Mr. Shayantan Sheth, Vice Chairman, ICARE, Mr. Shuriptan Sheth, Joint Secretary, ICARE, Dr. Sporshita Ponda Sheth, Vice Chairperson, Global Institute of Science and Technology, Dr. Bikramjit Choudhury, Principal, Global Institute of Science and Technology, Dr. Shubhimal Das, Registrar of Global Institute of Science and Technology, the joint conveners of the program, Dr. Gauri Shankar Pal and Mr. Ishan Shamonto, the coordinators of the program, Mr. Shobboshachi De and Mr. Jonardhan Sarkar, all the eminent researchers, the organizing committee, and all the enthusiastic participants. To speak a little about the concept of electric hybrid vehicle, it was first initiated by William H. Peyton. Mr. Peyton filed a patent application for a gasoline-electric hybrid railcar propulsion system in early 1889 and for a similar hybrid boat propulsion system in mid-1889. He went on to test and market the Peyton motor car, a gas-electric hybrid system used to drive tramcars and small locomotives. Modern hybrid electric vehicles make use of efficiency-improving technologies such as regenerative brakes, which convert the vehicle's kinetic energy to electric energy, which is stored in a battery or supercapacitor. Before moving on to a series of profound lectures, I would request our Principal Sir, Dr. Bikramjit Choudhury, to kindly inaugurate the program with his kind words. Over to you, sir.
Ma'am, please hand over the session to principal sir again.
Okay. Since we have Sir with us, so now I would request Dr. Bikramjit Chaudhary, our Honorable Principal Sir, to kindly inaugurate the session. Over to you, sir.
Yeah, thank you, Maitri. So, good afternoon to everybody. First of all, on behalf of Global Institute of Science and Technology, I welcome you all for 5 days international faculty development program on recent advancement and challenges in electric hybrid vehicle technology, organized by the Electrical Engineering Department of my institute. So welcome you all once again. Those are registered this faculty development program. Though I'm not in that particular field, then also I have the privilege to open that particular session. So I'm grateful for the organizing committee. Uh, So Global Institute of Science and Technology conduct this kind of faculty development program oftenly because this is the way actually we basically develop our faculties to share the knowledges, the expert talks, and somehow discussion session. In that particular way, we basically build up our faculties during their service career. FDP is essential for everybody, but today's topic, that is the hybrid and electric vehicle, that is the very popular in that particular current latest market. So in India, you all people should know that the EV are in the adoption stage. In each and every technology, have you should know that there are three particular stages. That the particular new technology, when it's in the initial stage, that is the adoption stage. In that particular stage, each and every company basically build up the technology. They don't have that price knowledges. They basically in the growing stage, that is the market in the upward direction. But after some years, that is in the saturation stage. That means when that particular technology in that in is in the position that in the competition, that is that every company basically looking for that technology, there is an monopoly is not available in the market. So that's why that is the saturation stage, that is the price tag is a little bit competitive. And if the technology is older, then the decline stage. So we can say in that particular electric vehicle sector, that is in the adoption stage in the Indian market. But parallelly in the IC engine, that means the petrol and diesel car, that is in the right now in the declining stage. That means that new technology, when that in adoption stage, the older technology is in the decline stage. So in that in EV vehicle, you know that in the market, the employees, the engineers are very few because lots of institutes are available, but they are not basically trained the student in that particular sector. So the employees are now very low, very few, we can say, in that electric vehicle sector. Because in the near future, if any student adopt that technology or the study on that particular field, they should get the success in near future. If we in India, if we basically um, adopt that electric vehicle, so our crude oil maybe India import the crude oil per year around $280 million. So that become decrease, or we can spend that particular money in the other sector or in the other new technology sector. In India now, in that electric vehicle, in two-wheeler, three-wheeler or four-wheeler, in a adoption mode, but in the commercial vehicle like truck or bus, there are few companies only the manufacturing the truck or bus in the EV sector. That is very few. We cannot adopt that particular technology in the commercial vehicle sector. Very lesser. Under our central government, the National Electric Mobility Mission Plan, in under the umbrella of FAME, that is fastest adoption and manufacturing of electrical vehicle, around 10,000 crore subsidy was declared by our government, that is EV manufacturing company, and 1,000 crore subsidy given for the charging station installation company. So that particular sector in our government basically highlight that in that EV area, that in the public, that is they should adopt that new technology, or those are the companies are in that particular technology, they should inspire. In central government, the road tax, maybe the income tax, or maybe subsidy given by the government, income tax benefit, that is also declared by our government to success that EV sector. Government also declared when the EV first launch in the market, that is in the around 2001 onwards, that is 28% GST. Now it is declined into the 18% GST, and our PM also proposed that it should comes down to the 5% of the GST. But it's right now the 18% GST, but it's proposed that it should be in the 5% of GST. You should all know that the CEO of Tesla, Elon Musk, basically feel their interest to come down to India for the manufacturing unit of the Tesla. And there is a big quote over there that we will not stop until every car on the road in electric. So this technology, there are lots of home-based company. Some other foreign companies are in the market. They basically are in a competition that now that EV should get the success. If EV should get the success, then our pollution level goes down and our economical benefit should be there. Lots of IITs, NITs and top level universities, they have their EV related courses. But EV not only depend upon the EV sector, basically not depend upon the engineers only. You can say the mechanical, automobile, electrical, electronics, computer science, the BTech, basically I'm talking about, they are having the good opportunities in that EV sector. The diploma students also have their future in that particular field, in the TV sector. They are act like a supervisor, technician in that new technology areas. But not only the BTech and the diploma, that is the technical line, the arts, commerce, these students are also having the good career in near future in that particular field. Because of that, this technology is now in the growing stage. So each and every sector, they have their opportunity on that particular skill based area, on the basis of their skill. they should have their, if they want to be in that EV sector, they should have their career, they should find their careers. Initially, the starting salary is the 5 figure, may be possible, but my think is that if we in the right now, if we start our knowledge gathering in that particular area, in the near future, within 2 3 years or 4 years, maybe those who want to their career in that EV sector, their salary may be in the 6 digit. So there are lots of companies are right now in the Indian market like Tata, Mahindra and Maruti. These are all Indian companies. Or maybe you can find out some other electric cars are available like Renault, Nissan, Volvo, Kia. These are some other companies. Hyundai is also there. They already launched their company, their cars, their brands in the Indian market. 2 3 years back, we can find around one or two car, maybe out of 100 in electric vehicle area. We can see the green number plate on that in the road. But nowadays, if the ratio goes higher, then it's maybe the 60-40 ratio. We hope that within 25 or 30, our 80 to 90% IC engine car may be converted into the electric vehicle. So hopefully this session conducted by the electrical engineering department is beneficial for everybody. I welcome on behalf of Global Institute of Science and Technology, the speakers. The speakers are Dr. Atan from Yüzüncü University, Turkey. Dr. Sagorika Pal, NITT Kolkata. Dr. Partho Sarathi Vomik, NIT Durgapur. Dr. Srijan Bhattacharya, RCC, IIT Kolkata. Dr. Shovik Ganguly, TIET, Patiala. So these are 5 speakers. They are having good experience in that particular field. So all the faculty members from my institute and from the other institute, those are registered in that faculty development program. I hope that this 5 days faculty development program definitely beneficial for you. And I welcome all the speaker once again. And today's speech after my session, that is Dr. Atan. I welcome you, sir. And I'm not getting that if anybody want to join, please join quickly, because Dr. Atan already in the panel right now, already joined this session. So on behalf of GIST, thank you once again, and hand over to Maitreyi. Thank you so much. Thank you, sir.
Hello.
Maitreyi madam, please take
Yes,
over the
sir.
session.
Okay. Thank you, Ishan sir. I would also like to thank our honorable principal, sir. And thank you so much, sir, for always enlightening us with your valuable words. So, dear participants, since we already have Dr. Ozkan Atan with us, in today's session, we are very privileged that we have Dr. Atan with us, and he will be sharing his notion on hybrid electric vehicles with us. To say a few words about Dr. Ozkan Atan, Dr. Atan is an associate professor at the University of Van Yüzüncü, Turkey. He received the MS degree in Electrical Electronic Engineering in 2007 on control of the electrical motors, and the PhD degree in 2014 on fractional order control of chaotic systems and optimization from Firat University, Turkey. He has been a student at Firat University in Turkey in 2008, and in 2014 he completed his PhD in the Department of Electrical Electronic Engineering from the same university. Dr. Atan teaches control systems, signals and systems, and communication systems at the University of Van Yüzüncü Il in the Department of Electrical Electronic Engineering since 2014. He was assigned to head of the Communications Department in 2014. He has been a visiting lecturer at the University of Thomas Bata at Zlin, Czech Republic in 2016 in the Department of Automation and Control Engineering as a faculty of Applied Informatics. In 2016, he finished project control of the twin rotor helicopter model, which was supported by Van Yüzüncü Il University. He was assigned in Technology Transfer Office as Vice Chief in Van Yüzüncü Il University in 2017. And then he was assigned as the Chief of the Technology Transfer Office in 2018. He continues his work as the Chief of the Technical Transfer Office and as an Associate Professor. Dr. Atan's research interests include synchronization and control of chaotic system, fractional order system, particle swarm optimization methods, and intuitionistic fuzzy logic control method. Now, I would solicitate Dr. Atan to kindly deliver his sublime talk on the topic Fuzzy Logic Controller for Parallel Plug-in Hybrid Vehicle. Over to you, sir.
Hello, can you hear me?
Yes, sir, you're absolutely audible.
Hello, everyone. My name is Ozkan Atan. Thank you for giving my informations. Firstly, I share my presentations.
Yes, sir. Dr. Gauri sir, Dr. Gauri Sagopan, kindly assist Dr. Atan for sharing his presentation.
Just a minute, sir.
So kindly click the present now option.
Yeah, okay. Okay. Now you can see my presentations.
No, till not now. Okay. Visible, sir.
Okay.
Sir, clearly visible. No problem.
Okay.
Okay. Thank you.
Hello, everyone. I give information about a fuzzy logic controller for parallel plug-in hybrid vehicle. My name is Ozkan Atan. I am associate professor in Yüzüncü University. Before my presentation, give about my CV, but I want to edit some things. I continue about fractional order system and control system, fuzzy control systems. I have a startup company about control and automation systems, applied novel industrial process, novel control methods. And I completed a lot of projects about in the university and industry. I give some informations about my projects. I completed rendezvous and docking control of satellites. We used the fuzzy control method in these projects. Another project, ground penetration radar and autonomous vehicle design for avalanche rescue team. Same time we used the fuzzy image processing in these projects. Another project we completed fractional order control system design. We use it in the fractional degree defined fuzzy systems. And now we continue our projects in control and automation systems. Same time we used it to in circuit and systems, memory store and another nonlinear circuits, passive circuits elements. Our presentations use a fuzzy logic controller for parallel plug-in hybrid vehicle. Firstly, we give information about series and parallel plug-in in hybrid vehicle. Firstly, subtate some sections about a hybrid vehicle, serial and parallel plug-in hybrid vehicle, control methods for parallel plug-in hybrid vehicle. Second chapter, we give information about novel fuzzy controller. Firstly, we give history of fuzzy system and classic fuzzy methods. After that, novel fuzzy control methods and logic systems, fuzzy logic modeling, and same topics, novel fuzzy logic control methods. Last section, I give information about fuzzy logic controller application in hybrid vehicle. We use it and parallel plug-in in hybrid vehicle for energy management and drive style strategy applications. After that, I give your questions. Firstly, we defined hybrid vehicle. Hybrid vehicle is a type of vehicle that uses two and more distinct power sources to move the vehicle. Typically, this power source included internal combustion engine and electrical motor, which work together to provide propulsions. The main type of hybrid vehicles: parallel plug-in hybrid vehicle, series plug-in hybrid vehicle, and serial parallel plug-in hybrid vehicle. Parallel plug-in hybrid vehicle in configuration both internal combustion engine and electrical motor connected to transmissions and can directly drive a valve. The Toyota Prius model is an example of parallel hybrid vehicles. Another types, series hybrid vehicle. In series hybrid vehicle, internal combustion engine is used to generate the electricity, which is then used to power the electrical motor that drive the valve. The BMW E3 with range extender is an example of a series plug-in hybrid vehicles. Lastly, series and parallel hybrid vehicle. In this combination and parallel and series hybrid vehicle configuration, allowing a vehicle to operate at either mode-dependent drive conditions. Chevrolet Volt brand is example on serial and parallel plug-in hybrid vehicles. Hybrid vehicles are known they improved fuel efficiency and reduced emissions compared to traditional gasoline powered vehicles. They achieve this utilizing electrical motor at a low speed during accelerations, while internal combustion engine typically less efficient. Parallel and series plug-in hybrid vehicle. I give when academic study on parallel and series hybrid vehicle examined, we obtained following result. Parallel and series plug-in hybrid vehicle in IEEE, there are 5,000 academic study, including 1,200 in journal articles. Another database, Science Direct, there are total into about 20,000 academic research. There are 1,000 journal article in 2024. Control for parallel plug-in hybrid vehicle in academic area. In IEEE total in 2,000 academic study, including 750 journal article. In Science Direct, there are a total of 4,000 academic research. There are 230 journal article in 2024. Academic research parallel plug-in hybrid vehicle have a generally focused control for driving style strategy and energy conceptions. Fuzzy logic controller can be better choice for this aim. Why? Because fuzzy logic controllers have flexibility and nonlinearity, simplicity, and robustness. Energy management systems. Fuzzy logic controller flexibility because can handle regular and uncertain inputs, which is common in real-world drive conditions. This flexibility allows to control adapted different driving style and condition effectively. Fuzzy logic controllers have a better than traditional control methods on nonlinear systems. In parallel plug-in hybrid vehicle have a nonlinearity because nonlinearity degree is higher than other systems. So fuzzy logic can be effectively modeled for control in parallel plug-in hybrid vehicles. Fuzzy logic can be provided robustness for these systems because fuzzy logic automotive can be used automotive applications. Energy management is specified into new car models because fuzzy logic can optimize energy management strategy hybrid vehicle, maximizing and full efficiency and minimizing the emissions. Overall, using the fuzzy logic controller for parallel plug-in hybrid vehicle can lead to more efficient and effective control strategy, improving vehicle performance and environmental impact. And now we defined and fuzzy logic systems. First, we defined what is the fuzzy. Fuzzy for this purpose of this lecture, fuzzy sets were defined. Everybody know by Lütfizade in 1965 as an extension classical notation of sets. After that, studies application on theory and continued increasingly especially fuzzy-based continued increasingly, especially fuzzy set mathematical model and mathematical analysis modeling and fuzzy-based controller systems. My projects, a lot of I continued a lot of projects of fuzzy control application to nonlinear systems in academic and industry. I have continued a lot of projects at now. There are nearly 3 million people about fuzzy logic system in academic paper database. Firstly, I give about fuzzy systems. Classical logics, if there are classical and fuzzy logics, comparative fuzzy and classical fuzzy logics. I give you an example about this presentations. I give presentations about in glass and water. In classical logic, to determine if a glass is empty, we can establish a clear criterion. For example, if there is no liquid in the glass, we can consider it empty. Full glass, similarly, in classical logic, to determine if a glass is full, we can set a specified level, level of fullness. For instance, we might consider glass full when it's more than half full. In fuzzy logic, empty glass state. In fuzzy logic, when determine a glass is if a glass is empty, we don't focus only on completely empty or full states. Instead, we can specify the degree of fullness to determine how empty glass is. For example, we might consider glass empty at 0% fullness and full at 100 fullness. Full glass, similarly, when determined if a glass is full using the fuzzy logic, we consider the degree and fullness. For instance, we might consider glass partially full at 50 fullness. Fuzzy logic can more flexible than classical logic and can handle more complex situations. Therefore, when determining if a glass empty or full, fuzzy logic might be more suitable because fullness of glass often doesn't have a clear cut boundary. Classical fuzzy, before classical fuzzy must define a crisp set and crisp logics. In set, crisp set and crisp logic concept are related traditional and classical logic and set theory, contrasting with more flexible nature of fuzzy logic, fuzzy set. Here, explanation both. Crisp set in set theory, a crisp set is a well-defined collections object either belong or don't belong to the set. Each element crisp set either a member 1 or not member 0 of sets with in not intermediate value degrees memberships. For example, set of even numbers less than 10. Crisp set containing the elements 2, 4, 8, 9. Crisp logic is also known classical logic to traditional form logic used in the mathematical and philosophy, where statement either true or false, no middle ground. In crisp logic, proposition signal true and false. The rule invariance logical operation in crisp logics. For example, statement it's raining outside either true or false in crisp logics without any consideration for degree truth uncertainty. In summary, crisp set and crisp logic based the idea clear binary distinction between element or true value in contrast to fuzzy natures. Classical fuzzy in classical fuzzy set and fuzzy logic, concept alone representation manipulating vague or impression informations. They are particularly useful in a situation that traditional binary logics set theory may be sufficient and describe the complexity of real world phenomena. Their explanation of both. One is a fuzzy set in contrast crisp set. Fuzzy set allows the element partial membership in a set. This means that elements can be belong to set to a certain degree between the 0 and 1 rather than strictly belong or not belong. The degree membership is determined by a membership function, which assign a membership value each element based on how well it satisfies criteria for membership in set. For example, tall people, someone who is 6 feet tall might have a membership value 0.8. Indicated height degree membership value, someone who is 5 feet tall might have a membership value 0.3, indicated lower degree. In summary, fuzzy set and fuzzy logics provided framework for dealing uncertainty impressions, allowing for more complexity and also representation reasoning compared to traditional crisp set and logics systems. When we designed a fuzzy logic system, there are 3 key components: fuzzification, rules, and the fuzzification. Here is an explanation of each. Fuzzification is process converting crisp input value into the fuzzy set. This is necessary because fuzzy logic operated on fuzzy sets, which allow the degree of memberships: low, medium, high, very high, very low, sign linguistic terms. Input variable type associated linguistic term that describe the input characteristic. Each linguistic term represented fuzzy sets defined in membership function. Fuzzification involved based on shape and characteristic of membership functions. Another key components in fuzzy logics, rules. Fuzzy logic rules define logic that governs the system behavior. Because these rules type expressions inform if-then statement where intended if part specify condition based on fuzzy sets of input variables, and consequent specify the output fuzzy set and action to be taken. Fuzzy logic rules are often written in human-readable format, capture expert knowledge, because fuzzy logic defined an intelligent systems, because you need an expert knowledge, intuitive reason about systems. Last key component in fuzzy logic systems, the fuzzifications. In the fuzzification is the process converting fuzzy output sets into the crisp output value. Since output of sorry uh, since output of fuzzy logic system is the fuzzy set representing a range possible value, the fuzzification is need to obtain a single action value. The fuzzification methods vary, but typically involve calculated center gravity centroid of output fuzzy set representing most represented crisp value for fuzzy output set. Other defuzzification methods include using weight average or selected maximum membership value as the output in fuzzy logic systems. Sorry. In summary, fuzzification converted the crisp inputs into the fuzzy sets. Rule defined logic of system based on fuzzy sets. The fuzzification converted fuzzy output into the crisp value for decision making or actions. This component together form basis fuzzy logic. At now, there are two input person charge and torque requests. For first input torque request, there are 5 degrees for inputs: negative big, negative 0, positive, positive big. For second input, there are 2 degrees low, high. There are 5 degrees for output 0, very low, low, high, and very high. And now, in this example, when we amount torque required increasing, battery power is low, amount of torque produced by internal combustion engine is increased. Thus, the need for electrical motor reduced. Similarly, when the amount torque decrease, that is, when it's not desired accelerate or goes downhill, the required torque of vehicle will decrease. Thus, need of internal combustion engine will decrease or even be go off, and it will be produce the energy and charge the battery. This is a classical fuzzy logic control design, basically. There are a lot of fuzzy control methods in literature. There are give information about fuzzy novel fuzzy methods, type 2 fuzzy, type 3 fuzzy, intrinsic fuzzy systems. Type 3 fuzzy logic in extension of a traditional fuzzy logic that allow for modeling or higher level of uncertain implications. In type 2 fuzzy logic, membership function itself is fuzzy, meaning that degree of membership of an element in a set is also fuzzy. This allows for a more detailed representation of uncertainty as a membership function can vary not only its degree but also its shape and characteristics. Another novel fuzzy methods, type 3 fuzzy is very basic applications about type 3 fuzzy systems. Type 3 fuzzy logic extension of type 2 fuzzy logic that further enhances the representation of uncertainty and impressions. In type 3 fuzzy logics, uncertainty modeling using a distribution function which allow for a more probabilistic approach to fuzzy reasoning. This enable modeling of complex uncertainty patterns cannot be adequately captured by type 2 fuzzy logics. In our presentation, we used intrinsic fuzzy systems and applications in this lecture. Intrinsic fuzzy logic is extension of classical fuzzy logic, allow the more nonsense representation of uncertain impressions. In intrinsic fuzzy logic, each element has three value associated: its membership value, non-membership value, and hesitation degree. In this three degree, all of this degree equal to 1. Okay. This approach allowed for more flexible representation uncertainty, as it can capture not only degree to which an element belongs to set, but also the degree to which it doesn't belong, and degree uncertainty or hesitation in between. In summary, intrinsic fuzzy logic and type 2, type 3 fuzzy logic allow extension traditional fuzzy logic systems. Intrinsic fuzzy logic system fuzzy logic introduces the situation where uncertainty not only due to a lack knowledge about the degree of membership of elements in a set, but also due to lack of knowledge about degree, non-membership, and hesitation degree. Sorry. Here are some key points about intrinsic fuzzy logic, its applications, membership, non-membership, and hesitation degree. Intrinsic fuzzy logic, in intrinsic fuzzy logic systems, each element has a three value: membership degree, and non-membership degree, and hesitation degree. This value represent the degree to which elements belong to set, doesn't belong to set, and degree of uncertainty, hesitation, respectively. Operators and aggregations function intrinsic fuzzy defined a set of operators and aggregation function that operated on intrinsic fuzzy sets. This operator included intersections, union, complements, implications, among others. They are used performed operation on intrinsic fuzzy sets. Intrinsic fuzzy set application, you can apply to a lot of scientific area, for example, decision making, pattern recognition, control system, medical diagnostics. All of them you can see best performance in fuzzy logic systems. I realized an 5 paper about intrinsic fuzzy logic system. All of these papers we can better performance into those systems. Overall, intrinsic fuzzy logic provided more comprehensive frameworks for dealing with uncertainty, hesitations, and impression than traditional fuzzy logics, making it suitable for a wide range of application where uncertainty is a significant factor. Fuzzification in intrinsic fuzzy set. Intrinsic fuzzy set, similarly classical fuzzy set, there are three key components: fuzzification, defuzzification, and rules. I give information about fuzzification at now. Intrinsic fuzzy set process converting crisp prices input value into the intrinsic sets, which consist of membership degree, non-membership degree, and hesitation degree. Different to classical fuzzy logic systems, we added a hesitation degree. Okay. This process allowed the representation uncertainty, vacuum, and hesitation in input data. During the fuzzification, membership degree represented the degree which element belonged to the set. Non-membership degree represented degree which element doesn't belong to the set. Hesitation degree represented degree of uncertainty. Hesitation in membership and non-membership degree. Okay. Fuzzification typically performed using linguistic terms describe the input data and membership, non-membership, and hesitation degree assigned based on degree which the input value satisfy characteristic of each linguistic term. For example, the fuzzification temperature is linguistic term such as cold, warm, hot. Eclipse temperature in 25. Membership function will be 0.7. Non-membership value in 0.2. In hesitation degree 0.1. Okay. Summary and fuzzification in intrinsic fuzzy set allow the representation of uncertainty and hesitation in input data, assigned membership, non-membership, hesitation degree in linguistic terms, based on how well the input values satisfy characteristic of each term. Another key component in intrinsic fuzzy system in rules. Intrinsic rules are used to define a logical expression relationship between the input value and output variables. These rules similarly use the traditional logics, fuzzy logics, but additional component account the hesitation uncertainty associated with each variables. Intrinsic fuzzy rules are typically expression into form of if-then rules. Generally form intrinsic fuzzy rules if X with membership degree, non-membership degree, hesitation degree, then Y equal to B with membership degree, membership, non-membership degree, and hesitation degree. You can give a classical fuzzy logics rules, but differently you can add it hesitation degree between two input and output. Last expression about the fuzzification in intrinsic fuzzy sets. The fuzzification fuzzy output set converted the crisp value. In intrinsic fuzzy logic, output set consisted of three values of each linguistic term, sign, fuzzification, and rules. membership function and non-membership function and hesitation degree converted to output crisp output values. The falsification aimed to derive a single actionable value from these fuzzy sets. There are several methods for the falsification in intrinsic fuzzy logic, including same classical fuzzy logics. Or intrinsic fuzzy logic, the falsification method, including centroid method, height average methods, and other methods that are classic in the falsification. Centroid method, this method calculated weight average of output value based on their membership degree. The formula for the centroid of an intrinsic fuzzy set, and similarly to centroid formula used a traditional fuzzy logic, but it also taken into the account hesitation degree. This method output value with a highest membership degree is selected as Crisp output value. If there are multiple output value with a same highest membership degree, the one with smallest hesitation degree is chosen. This weight average method calculated the weight average output value based on their membership degree, non-membership degree, and hesitation degree. The weight are determined by this degree, with higher degree contributing more to final value. The other methods, there are other falsification methods, same traditional fuzzy logics, but generally use the weight average method, centroid method, but there are a lot of the falsification method. The falsification in intrinsic fuzzy logic aim to provide a single actionable output value that represented the overall result of fuzzy reasoning process. The choice of the falsification method depended on specific application, the desired characteristic output value. Sorry. Fuzzy logic application in hybrid vehicle energy management strategy. If the fuzzy logic I give information. Okay. Fuzzy logic controller application in hybrid vehicle. You can see that algorithm in right side. Firstly, if the torque request goes negative, engine is torque equal to 0. Motor generated charge battery. If then the request goes positive, it's time to judge battery percent of charge is a little lower than low threshold. For example, 0.2. 0.24. In order to avoid excessive discharge, battery doesn't provide the power and engine provided entire power. When percent of charge is higher than 0.25, necessary to compare to request with term electrical motor torque electrical motor maximum level. In this case, if the torque required is less than the motor maximum torque of electrical motor maximum value, in order to make a full uses in electrical energy. The engine turn off entire torque is provided by motor. When the request to torque is greater than the torque of electrical motor maximum level, the motor still output maximum torque, and residual torque is provided by engine. This approach utilizes battery power. So when we make braking, you generate the electrical energy, charge it to battery. After that, you use it another times you go to on the road. So this electric hybrid vehicle, so there are best performance into the systems. Sorry. For an intrinsic control systems with an two input, percent of charge and torque request, we need to define a membership, non-membership function for each input variable and hesitation degree. This function describes degree to which given input value belong to or and hesitation degree. If you can see that this membership and non-membership function, membership function and non-membership function, if sum of this value is smaller than 1, but if between two error this value equal to hesitation degree. Same torque request and battery cent of charge. Just a minute. It considers linguistic term each input variables, a percent of charge, linguistic term low and other side height. Membership functions, there are 5 linguistic term in power, battery per percent and charge. Membership function, this function defines and shape of characteristic, the fuzzy sets for each linguistic term. They can be triangular, trapezoidal, and Gaussian, or any other suitable shapes that represented input data distributions. We use it in triangular and two shape for fuzzification, triangular and trapezoidal shape into fuzzifications. Non-membership function, this function represented the degree to which input value doesn't belong to a linguistic term. They are typically component of membership function. Another value function, hesitation degree. Hesitation degree, I say that between two membership and non-membership value. Another input torque request of torque of our vehicle. There are 5 linguistic terms in negative bit and between the positive big value. Membership function similar to percent. The membership function for talk request define the degree to which input value belong to each linguistic term. Non-membership function similarly, non-membership function requested degree which an input value doesn't belong to each linguistic terms. This function provided maps. In this is rule-based for intuinistic fuzzy systems or novel fuzzy logic control application in parallel plug-in hybrid vehicle. In here, our output engine torque membership and non-membership function. You can see that output the fuzzification membership and non-membership function. In here, our percent of charge. When we higher, we use it to electrical motor. If we take an torque requested to electrical motor, we use it the electrical only electrical motor. But our torque request increase it. We not take the electrical motor this torque. We use it and gasoline traditional gasoline motor. Same. For example, when we battery is go to down, we use it to electric gasoline engines. Same times. When we use it the function in here, we use it the urban distribution area or speed change. We use it data. We can take a lot of value in compared to systems. Okay. My presentations is completed. I want to give you times for questions.
Madam, please take over the session.
Sorry, I can not understand you at now. Please repeat.
Well, now session is open to all. Thank you, Dr. Atan, for this wonderful presentation. And now this as the session is open to all, so participants are requested to unmute and ask questions to Dr. Atan.
Sorry, your voice is very. There are noise. Can you repeat it now?
Hello.
Okay,
Hello.
I do.
Now is okay.
Hello.
Hello.
Yes. May I have a question? Question is that for biomedical information systems, for example, we have to develop some eye tracking for eyes. The fuzzy controller we want to use. Main thing is that fuzzy concept is some haziness is there, accuracy and performance for detecting eye tracking or other in medical devices. It is a challenging issue. how we could enhance the performance.
You want to learn application of the medical device, right?
Yes. Exactly.
Medical device is very wide area. There are image recognition, pattern recognition, and medical device control systems. Your I can firstly you define it, your medical systems. For example, you can define it an image into medical systems. We applied paper in conference paper for medical image recognitions. There are have best solutions into intrinsic fuzzy system applications. Yeah.
Good. Thank you.
You're welcome. Another questions?
Another questions I have in mind, particularly for biomedical information systems, here blood pressure or blood sugar. Some of the area new types of emerging technologies coming for testing the blood sugar by CD eye vein pressure, eyesight vein pressure. Just take the image, how it is coming ready. So these types of things, new types of things coming here. We have to using some types of fuzziness, fuzzy. My question is similar to that for accuracy. If we use some fuzziness instead of clip set or that 0 1 binary, instead of fuzziness, we'll get more better result or output or performance.
Sorry, your questions about fuzzy logics, but right?
Yes.
Fuzzy logic systems is defined an uncertainty. So is there are give you robustness for control systems in image recognition and image analysis. Give you best solution because your image have a noise and other environmental impact. So you use the uncertainty define it and membership functions. If especially you use it in intrinsic fuzzy systems, you define it and hesitation degree with uncertainty. So you can get best, maybe not best, but better than solutions in classical systems. So it's important this image recognitions on other control systems.
First we have to simulate, then we have to implement in the controller systems. Practical implement.
Yeah, fuzzy control systems is maybe fuzzy control system knowledge, expert knowledge. So is we can say that is more than complex the classical PID control and other control methods. But fuzzy give you robustness in nonlinear control, nonlinear industrial system, and nonlinear physical systems in the real world. So we can use it and fuzzy control system into the expert knowledge. Is hard for you to define it, the rule-based and membership function. So it's hard. But if you completed your process, sorry, it's completed your expert knowledge. It's not problem is working to your systems. Another complexity into fuzzy logics. There are need a lot of programs sites. So program lines, because you give in for example 7 linguistic terms to inputs. You use it for 49 line for compared to your microprocessor. It's hard for your systems, but at now it's not problem microprocessor, because our microprocessor is very high speed, so it's not problem at now.
Okay. Thank you.
You're welcome.
Hello.
Hello.
I have just one question in this regard. Actually, sir, you have just narrated the application of fuzzy control system in the electrically hybridized vehicle. So, if we just go in some other way, like just by consulting the ANN architectures or the CNN architectures using the deep learning. So, would there be any kind of benefits of this kind of machine learning approach over the soft computing?
Yeah, machine learning systems, you need to requested a memory more than, for example, you need to 1 terabyte data into your systems, and you need to high speed microprocessor, because you continue to your data processor, so it's hard for you. But in fuzzy logic, it's not have a same complexity. So first, only you need to one microprocessor you can work in your systems. Your machine learning systems may be better than result for your systems. So it's very basic solutions, give you basic solutions in fuzzy logic systems. But in last year you can apply to a fuzzy logic system with machine learning system, because in you need to expert knowledge into your systems. Expert knowledge provided by machine learning systems. So you can use it together, machine learning system and fuzzy logic systems. Okay.
Okay, thank you, sir.
You're welcome. Are there any
Is
questions?
there any other question from the participants' end? So I guess we are not left with any more questions. And once again, I thank you, Dr. Atan, for being with us in today's session. I would now request Dr. Gauri Shankar Pal, sir, to kindly present the memento as a token of appreciation and respect to Dr. Atan.
Thank you. Thank you very much. Can you share me with this present?
Okay, sir, I will share. No issue.
Okay, thank you
So
very
sure,
much.
I will share the certificate and memento yeah, via mail. Okay.
Okay.
Okay, sir.
Thank you very much. Your listening. If you can reach my mail. We can continue to collaborations with you and your students. Realize a lot industrial project and academic projects. Okay. Thank you for your rate. Thank you.
Thank you so much, Dr. Atan, for being with us in today's session. I would also like to thank all the eminent dignitaries of Global Institute of Science and Technology for allowing us to arrange this faculty development program. And I truly believe that without their aid, it would not have been possible on our part to conduct this program. I would like to express my gratitude to all the participants for their presence, the entire organizing committee, and the advisory board of Global Institute of Science and Technology. On this note, I would like to call it a day, and the feedback link is there in the chat box. So I would urge the participants to check the chat box and fill the feedback form. Thank you so much, everyone, for your presence. Have a good day. Thank you.
Bye bye.